a separate company. So we still want to keep that brand name recognition. So as you throughout our literature, Truss Joist is still mixed in there, but it's not a standalone company. In the beam products, or what we call rectangular sections, we use that same technology to do a variety of products: beams, rim boards, columns, and studs. And again, the three technologies that I spoke of, and I'll go a little bit more detail after. And then we also manufacture OSB panels. Okay, so here's an example of an OSB. Okay, we would use this typically as a floor sheeting, or as a wall sheeting, or as a roof sheeting on top of your trusses. Okay. We have two brands, Edge and Edge Gold. I won't spend a lot of time on that today, but Edge is basically the commodity, everyday flavor of OSB. Edge Gold is kind of a value-added panel, a higher performing panel with different glues and resins, so it resists weathering better, so the edges don't swell, has a bigger warranty, different stuff like that. So, okay, so very few, if any, other manufacturers would manufacture all of the components like this that would make a structure. Okay, so there are other I-joist manufacturers out there, but they don't make their own rim board, for example. They'll just use a generic OSB, a thicker OSB as a generic rim board, whereas we make our rim board out of timber strength for this product. Okay, and there's some advantages structurally and stuff like that. We see that road. So we really have the whole package, and we have a whole set of tools and literature and full library, all kinds of information that helps specifiers and designers and what have you work with our products. Any questions at all? Good. All right. So here's an overview of the I-joist. Again, what we call the TJI. Again, to recap, the part of the reason for creating it was to eliminate some of the imperfections. You see some cuppings and cracking, some splitting. An I-joist, because of the way it's manufactured, we can control the integrity of this panel. We can control the strength of all of these flanges. So we can make essentially every I-joist that we make virtually the same strength. So there's not a big variability from one joist to the other. You won't get the shrinkage and twisting and warping and cracking that you would with traditional solid sawn lumber. So from a floor performance standpoint, a lot easier to design, a lot easier to build with, because every piece is usable. You don't have one that's all crooked. You got to throw it in a dumpster. So and far more predictable for floor performance. So builders like it because they know what to expect for their homes, for the homeowners later. Products such as that comes with warranties attached to them, so it gives some peace of mind to the homeowner long term. So there's a bunch of advantages to engineered wood in general, and in Ottawa, for example, or in this market, probably, I'd say 99% of what gets built residentially will be with engineered wood like that. Very little solid sawn lumber in this market. Some markets like Toronto would still have quite a bit of 2x material, simply because a lot of the homes are much smaller, the lots are so small, so they could actually, in many cases, still get by with a 2x8 as a floor joist, because the spans are so short. So that being said, a 2x8 is significantly less expensive than your average I-joist, so it's a question of dollars and cents why they still use, in some markets, solid sawn lumber, but generally speaking, it's mostly engineered wood. All right, so the way engineered wood, or the way an I-joist is made, you either take 2x3s, 2x4s solid sawn lumber, or you take LVL such as this. It's manufactured in a big billet. You cut it down for the proper width of flange that you want. It's routed essentially, and then it's run through a continuous press that runs about 300 miles an hour. It's super, super fast. And basically the top piece and the bottom piece get connected with the web. The web is kind of interlocked. See it on this short sample, but there's kind of like a zigzag pattern to the web, and there's glue inside, and it's locked in place, and it just runs like a sausage. So we're really limited to trucking for the length that we would ship out. Most commonly, we'd see 40 furs in a typical lumber yard. So they buy really long lengths because that's all on a flatbed truck and usually carried, and then they cut it down to length depending on what's needed in that given floor package. Okay. So an I-joist can also be used as a roof joist. Here's a snapshot of it there. Some kind of particular details when it comes to roof framing. Because you're dealing with an eye profile, there's some limits to what you can do versus the traditional old school stick frame type roofs. You don't really, very difficult to accomplish that with an eye joist. So typically you should be shy away from that. So we'll get into some of the roof details a little bit later. But some clear-cut advantages to using an eye joist in a roof system. Floor performance isn't so much of an issue because it's on the roof, nobody's walking on it usually, but the depth is a big bonus. You can get an eye joist anywhere from 9.5 to 16 inches deep, which is kind of the everyday items. You can even get it 18 and 20 inches deep. So that would give you plenty of room to insulate and still have room for ventilation. If you have a 16-inch deep eye joist, you can have your R40 or R50 and still have room for ventilation. Okay. And you can also get really long pieces, so if you've got a really high cathedral ceiling, you've got 20-foot pieces or something, you can accomplish that in an eye joist, but it's very difficult to do it. So here's just a quick snapshot of one of our product lines here. That this is the LVL flange. And again, it has different widths of flanges for the most part. The flange width isn't always the indicator of its strength. You'll notice that our 230 model and our 360 model are basically the same size, 2 and 5/16 wide, but the grade of LVL is different. Okay, so don't be fooled by two eye joists being one side by side that they're the same strength and they're just interchangeable, not necessarily. And the same goes for solid sawn lumber. Okay, same goes for this is another line that we have with 2x3 or 2x4 flanges. Every joist out there has proprietary design values. So the grade of the 2x3 or the 2x4 are not the same from one manufacturer to another. Everybody has proprietary grades. So it's not all number 1s and 2s. Put a bit of glue and you run through your router and add a bit of salt and pepper and boom, you have a joist. There's a lot of technical stuff in there, the type of resonance, the shape of the route, and all kinds of stuff like that. So in our case, we use MSR grade flanges in our eye joists. So each and every piece of wood is machine stress graded. MSR, that's the acronym. Okay, which is much different than the average 2x4 that you'll find in your wall framing, which would be a number 1 and 2 or 2 and better. So there's a variety of grades of lumber, and there's typically specific grades that are used in an eye joist, and every manufacturer has a proprietary grade. Okay? Same goes for the OSB that's inside the web here. That as well, it's a web stock, it's specially designed so that for higher strength and shear and stuff like that. So we'll get into this a little bit later. So that's an overview of what an eye joist. So terminology, this would be what we call the flange or the cord, top and bottom flange. This would be the web. Okay, so that's kind of industry standard stuff. Rim board, like I said, we manufacture a rim board as well. We make it out of timber strand. And the rim typically will do the outside perimeter of your floor framing. It plays a very important role when it comes to vertical load transfer. So all your exterior walls that come down, carrying roof load or what have you from above, it all gets passed through the rim board down into the foundation all the way through. The fastening of the rim board on the wall below or on the sill plate that's on around the foundation is what helps keep the building on the foundation. So when the wind blows over here, the rim board that's nailed all along this wall is what's preventing the building from getting blown off the foundation. Okay, so the rim board, very, very important. There's a few different details that can be done for an outside perimeter. You can actually use an eye joist as an outside perimeter as well. It just doesn't have as much vertical load carrying capacity. It's a little finicky, a little bit harder to frame with. When you want to put your exterior finish, for example, you want to have something solid to nail to. If you want to lag on a deck, you can do that. You can anchor that to a piece of rim board where it's not the same with an eye joist. So most of the time you'll end up seeing a rim board, but it's not necessarily mandatory. So that was the eye joist. Now into the rectangular products, a little bit more detail. Start with timber